the theorem which we learnt in the previous module, that is the radius is perpendicular to the tangent. Let's start with a very interesting sum which is supported with a figure. Over here the question goes in the following way. From a point Q, the length of a tangent to a circle is 24 centimeter and the distance of Q from the center of the circle is 25 centimeter. Find the radius of the circle. Here, as you can see in the figure, the center is point O. First and foremost, the distance of Q from point P is given as 24 centimeter. It's a tangent whose length is 24 centimeter. And the distance of point Q from the center, that is O, is given as 25 centimeter. We need to find the radius of the circle. In the figure, PO represents the radius, so we need to find how much is PO. If you look at PO, it definitely belongs to a triangle. So let's consider triangle POQ. In this triangle POQ, let's understand what else we know. Look at angle QPO. Now, if you look at angle QPO, its one arm is a tangent and the other arm is a radius. And we know the relation that radius is perpendicular to the tangent. Hence, angle QPO will be 90 degree. So we now say in this triangle, angle QPO is 90 degree, radius is perpendicular to the tangent. That means triangle POQ is definitely a right angle triangle. And in this triangle, we already know the lengths of two sides. And to find the third side, let's apply the Pythagoras theorem. And we now say OQ square is equals to OP square plus PQ square by the Pythagoras theorem. On further substitution, we now say 25 square, that's OQ, is equals to OP square plus 24 square. That's the value of PQ that we already know in the question. Further, 625 is equals to OP square plus 576. So now when we swap it, we now get 625 minus 576 is equals to OP square. Hence, OP square is equals to 49. So when we take the square root, OP is root of 49, which should be equals to 7 centimeter. That means the radius of the circle is equal to 7 centimeter. Let's take one more question on the same lines. Again, this sum is supported with a figure. And the question goes in the following way. The length of a tangent from point A at a distance 5 centimeter from the center of the circle is 4 centimeter. Find the radius of the circle. So over here, first of all, point A is at a distance of 5 centimeter from the center. The center is O. So O to A is definitely 5 centimeter. And the length of the tangent from A to the circle, that is AB, is equal to 4 centimeter. We need to find the radius of the circle, which is represented by OB. So let's find OB. Now here OB belongs to a triangle, triangle OBA. So let's consider this triangle. In this triangle OBA, let's look at angle OBA itself. If you look at angle OBA, we realize that line AB is a tangent and OB is the radius, and we know that radius is perpendicular to the tangent. Hence, angle OBA will be equal to 90 degree. That means, children, this triangle is a right angle triangle. And again, we know the lengths of two sides, which will enable us to find the third side. Let's apply the Pythagoras theorem. Hence, OA square is equals to OB square plus AB square. We can write it anyhow by the Pythagoras theorem. Hence, 5 square, which is OA square, is equal to AB square, that is 4 square plus OB square. Now we know 5 square is 25 and 4 square is 16. Right? Let's expand this. Let's bring the numbers together. Hence, 25 minus 16 is equals to OB square. Hence, OB square is equals to 9. That means OB will be equals to 3, right? 3 centimeter, we should say. Therefore, the radius of the circle is equal to 3 centimeter, and that's what we need for the sum, children.